Question J, and suddenly we've got a whole lot of numbers with us. So, although we've got this for reference, this tan theta equals sine theta, I mean, we wrote that down, we got it for reference. Not sure how much we're going to use it because, well, maybe, but we're ending up with 1. I mean, when I say ending up with 1, I mean, if we've got the left-hand side equals the right-hand side, well, that's what we're trying to prove. Which part do you think we're going to be simplifying? Well, clearly the left-hand side, right? It's not like we're going to simplify 1 and turn it into that. You could, but no, let's not go down that route. So we see 70s, 175, 340s, 185s. I'm thinking reduction. So as much as this was useful, the stuff here, we've got it there for reference, but what's going to be more useful is to have our CAST diagram. So we're going to have a little CAST diagram, C-A-S-T, and that's what we're going to be using with, of course, our sneaky little tool called the calculator at reference just in case. Sine 70. Now, we're given this fraction, so I'm just going to tell everyone that we're doing the left-hand side. What do you think we can do to all of those? What were we doing before we were even proving identities? What were we trying to do with these angles? Well, I'm hoping that you're thinking along the lines of turning them into acute angles. So that it was always going to be 70 or 80 or 60 or 30 or 35. So let's do that. Sine 70, let's leave as sine 70 degrees. So I'm going to stick with this tactic of scribbling over each one with a different color. And then look at cos 175. Now cos 175, we can look at it, looks close to 180, right? So when we say that 175 is sitting over there, it's still got another 15 degrees to get to the x-axis, to 180. So that's the same as cos 180 minus 15. Well, really what we're saying is if we're dealing with 180 and 360, cos stays as cos. But instead of cos of 15, we need to think, is it positive or negative? Or we in sine's quadrant, in the second quadrant, so therefore it must change to a negative. Okay, let's keep going around and saying, well, cos 340. I like to go for the 180s, 360s if possible, because then we don't have to change causes to sines and sines to causes, but it might not always be possible. So what we're saying here is that's sitting down here, right? Cos of 340. So if that whole outside angle is 340, this last little bit should be 20. So this is going to stay cos, because we're going to the 360, we're going to the x-axis, which means cos stays cos of 20. Now we need to work out, is it positive or negative? In that quadrant, it's positive. Now I hope you're just checking that you got the answer right, or you watched the first bit of the video and said, oh, okay, I know how to do this already. Maybe you're not watching this. Well, you must be if you're listening to this, but you know what I mean. But my point is, pause. Don't just keep watching the video to see what I do with cos 185. You need to hit pause and then try it and see where you're going to get to. Okay, let's do this though, because maybe now you're watching, you've tried it and you're going, oh, that one didn't quite work. Cos 185. Well, 185 sitting over here. If we do it to 180, it's closest to 180, right? It's just 5 degrees off. So it's going to be cos 5. But wait a second. We're in this quadrant, third quadrant, tan quadrant, so this should be a negative. Now, let's say, well, this is going to be equal to, we've got negative over negative, so the whole thing is going to be positive. Now, as we did before, we can say, well, sine of 70 doesn't give us a nice answer anymore. So we can't just punch this into our calculator. But we need to somehow start making things cancel out quite nicely so that our final answer is 1. Now, I've made a clumsy error, haven't I? What have I been doing? This is 15. Sometimes you've got to worry, don't you? But, warts and all, right? Let's show this in full to go, well, this should have been 5 degrees. 175 is 5 away. So those two are going to cancel nicely. And I'm thinking ahead to think things should cancel quite nicely here. So I'm going to cancel this whole negative cos 5 with this negative cos 5. Okay, maybe you watched it and you thought, wow, what is he doing? Now we've got sine 70 over cos 20. Let's just write that so we can concentrate on this. Now, how are we going to simplify this? I'm saying that these aren't nice angles as in the special angles where you punch in your calculator and then you just write it down and simplify. Remember our freestanding triangle. So it should be able to fit in here. If we have sine of an angle, so if this angle is 70 degrees, sine is going to be this side, let's call it A. So if we've got ABC, it's going to be A over C, opposite over our hypotenuse. But what about cos of 20 degrees? Won't that be A over C? So in other words, we need to use our 90 minuses now. So we can say this is the same as, well, sine 70 we know is the same as cos of 20. It's getting to 90. And we just look at our freestanding triangle to go, well, sine 70 is cos 20 because sine is opposite over our hypotenuse, but cos is adjacent over our hypotenuse, so those are the same, and we need to just have those ready to go. That was cos 20. These cancel nicely to give you 1. That looks like not equal, equals to 1, which is our right-hand side. So a few things along the way all relied, we didn't use this at all, but we did use our reductions and we used our 90 as well. So that was quite something. That was a nice question, right?